So, how do we design it? So, let us say I have 3.6 volt input and so I want to achieve. So, this is my V in equal to 3.6 volt and I want V out equal to 1.2 volt. So, what can I do? How can I generate? Can I do this? R1 and if this is my R load, or let me call it R in. So, if I just add a series resistor in the supply, I can drop the voltage. So, if I drop 2.4 volt across that R in, my output will be 1.2 volt. Okay, so, what is your V out? R load over R in plus R out multiplied by V in. So, if R load is changing, so will V in remain V out will remain constant? It won't remain constant. Okay. So, varies with load current and V in also. Correct. So, which means this implies we need to vary R in if V in or R load V in or R load is changed. Okay. So, if I find a mechanism where V out equal to R load over if I can control this R in, then I can regulate my output. Okay. So, what do I need to control the R in? So, I need a feedback, okay, which means if this is your R load, control, which what it will do basically, it will vary this guy R in so now this control what it will do, it will compare this with Vref, V out, and accordingly it will change the R in to make sure your V out is constant. Okay. So, can I do the same thing with this also? So, instead of resistor, if I have a current source, so this is your feedback control, which compares with the Vref, and you will achieve the same result. So, which means your I in equal to I load. So, if your I in is varied based on the load current, whatever load you require, and it will supply the same load current, then your output will remain constant. In the previous case, you just control it with the resistor divide ratio. So, if your input voltage or your output current is changing, you just change the input resistor, so that your output is regulated. Okay. So, that is the whole concept behind your regulator, which means you have to build this resistor or this current source. Okay. And how do we do that? So, we do it using, we call it pass element. Pass element is nothing but your current source or resistor. Okay, I or R. This is your V in or VDD, whatever you call it, and this is my V out. This is your R load. This is my V out. What you do, you have a feedback system. This is some high gain amplifier, the negative feedback Vref. What you get a control voltage here Vc, and this will control your pass element, that will in turn control your R or I. Okay. So, I is GM of it is not Vc actually, but let us say Vc, it depends on V in also, but a small signal will be your Vc. R equal to, so I will just add proportionality factor proportional to Vc. Okay. So, now you can control your R with Vc or control your current with Vc, and this is your voltage controlled current source, and this is your voltage controlled resistor. So, you can use either of the two, you can use resistor or current, but most of the time we use current. Why do we use current, why not resistor? So, MOSFET, if you operate your MOSFET in a triode region, it will behave like a resistor. If you operate in saturation region, it will behave like a current source, but most of the time we use in saturation region. The obvious reason is your PSRR. So, we will talk about that. We saw that you have a negative feedback with the pass element, and where pass element could be a current source, voltage controlled current source or resistor, and these pass elements can be so they could be your P MOSFET, and MOSFET, PNP, so they could be bipolar or MOSFET transistors, and since we mostly use CMOS technologies where we do not get freedom of having bipolar devices, active bipolar devices, we get only these parasitic bipolars, which we looked into a band gap reference, where your substrate is grounded, which forms the collector, and you just tie the base with the collector. So, that is parasitic. So, that is why we do not have a freedom to use bipolar. So, we mostly use these two. CMOS process technology. In some high voltage process, we have a BCD MOS where we call bipolar CMOS DMOS devices. There we get these bipolars. So, if you have that process, special process, then you can use bipolars. Otherwise, for a standard CMOS process technology, we use PMOS or NMOS. And PMOS is the most commonly used pass element, and we will come to that. There are some places where we use NMOS also. Both have their own advantages and disadvantages. So, we will talk about PMOS LDOs and NMOS LDOs both. Okay. So, in order to design a linear regulator or LDO, so what we require? A pass element and error amplifier, and we have a load. So, error amplifier is nothing but your op amp. It could be single stage or two stage depending upon your gain requirements. And since it is connected in a feedback loop, we have to analyze the stability behavior, and which is done usually using AC analysis. Okay. So, you have to always do a small signal or AC analysis of your LDO in order to make sure that it is stable. So, in order to do AC analysis, what do you require? How do you do AC analysis or stability analysis for any system?
Break the loop.
Yeah, break the loop, but that is fine. But how do you do actually? What tool you use? Yeah, so you require Bode plot. Okay. So, first you need to understand the concept of feedback. Okay. Negative feedback. So, any stable system is designed using negative feedback. We never want our feedback to become positive, otherwise it will become unstable. What do you understand by a system becoming unstable? What happens if system is unstable? Can anybody tell? Output is uncontrolled, okay, which means it may oscillate or may not oscillate. Sometimes people say, okay, unstable means it is oscillating, but that is not true. If it is not bounded, it is unstable. So, it could be it may have oscillation or it may saturate to your VDD or ground actually most of the time. So, one classic example of your unstable system which is not oscillating is your Schmitt trigger. Okay. In the Schmitt trigger, what happens? Your output is a square wave. So, it basically your whole system, instead of behaving like a linear system, it becomes a non-linear. Okay. Non-linear means you do not have a input output characteristic not linear, but it has only like a 2 points or so. So, it will either go to VDD or ground. So, it is completely becomes undefined between your 0 and VDD rail when you change the input. Okay. So, there is no as such direct relationship, linear relationship between input and output. So, it only acts at a certain threshold, just like a comparator. Okay. So, if this has a gain of A, so what is the transfer function of this? A over 1 plus A beta. And what do we call this A beta? A beta is the loop gain which is nothing but your open loop. Okay. So, whenever you have to find the loop gain, you have to break the loop because it is defined as a open loop gain. And what is the, so this is your negative feedback, obviously, this guy. Now, if I change the sign, I make this positive and this negative. So, what is the transfer function now? So, let us say A beta in this case is there any condition where this V out by V in will go to or output will go to infinite in this case? Forget about sign. Is any values of A beta product positive values which will make it infinite? No, because if it's a 0, then it will become. So, if it's a 0 means open loop, okay, because beta is 0 means you open this and your open loop the gain of this op amp is A. So, it will simply become A. So, the maximum loop gain you can achieve from this is basically A here, because beta is mostly less than 1 in the feedback factor. So, in the open loop you get a 1 A, and when you have a beta infinite, then it becomes 1 over beta. Okay. In this case, is there any value which will make the output infinite? A beta equal to 1. Okay. Unstable. So, which means in order to make this system unstable, it has to be a positive feedback, but we always operate our system in the negative feedback. So, how does it become positive feedback then?
Particular frequency of gain of the amplifier.
So, now take this negative feedback again. (180° phase shift). So, if this was positive, this will become negative. Now, negative will become positive. So, if in your loop you have a 180° phase shift, then it will make your negative feedback into a positive feedback, and if your gain is becomes 1 or more than 1, then it will become unstable. So, there are two conditions. Two conditions for unstable system: A beta greater than or equal to 1 and angle of A beta equal to 180°. Why gain A beta more than 1?
Because it will shift the pole towards right. And if the loop travels,
That is a mathematical. So you have to look around the loop. So what you are doing, you are taking the output and feeding it back and amplifying. Okay. So if your A beta is less than 1, think about every time you multiply by a number which is less than 1, it will keep decreasing. If you have a k to the, let us say k to the power where k is less than 1, so let us say 0.9 power infinity, it will become 0. So, and that is what happens when you travel around the loop. It is basically if you make it convert it into a sampled system, then it will become a clocked system. Here we are looking at continuous, but in order to understand, you can think about it's a clock system. So every clock cycle you are sampling the output, feeding it back, sampling, feeding it back. But if you are multiplying that by a number which gain which is less than 1, then it will decay and it will never increase, build up. So it will not be unstable in that case. So even if your phase shift becomes 180 degree, your gain is not sufficient, your output will not oscillate, or it won't go to VDD or ground basically. It will basically converge, okay, die out, or your oscillations will die out if it is a second order system. That is why we require A beta greater than 1 or equal to 1 is the ideal condition. So where does this phase shift come from? So loop gain, you know, that is coming from your op amp has some gain and your you have some beta factor feedback. Now, so A beta is already there. Now you need a phase shift. So if there is no phase shift in the LDO, it is straightforward. Then you don't have to worry about stability and anything. So
beta is a function of frequency.
no, function of frequency. What do you mean by function of frequency? Why? Why it's a function of frequency? Huh? Okay, so your introduced by R and C. Okay. When I say R and C, let me make it even clear, by combination of R and C.